Now you may want to go from binary and decimal to binary, decimal, and hexadecimal numbering systems. What's the biggest difference here? Well, decimal is based upon the base 10. So we're going to have all the numbers 0 through 9 available to us for any number that we would like to make. That's what we have been learning in math class throughout our entire educational careers. Binary has two values, 0 and 1. Utilizing a series of up to 8 bits, we can make any number from 1 to 255, which is more or less good for all purposes for what a computer can use them, at least in the networking arena. On the other hand, hexadecimal uses values that is base 16 values from 0 through F, which is in effect 0 through 9, and A for 10, B for 11, C for 12, D for 13, E for 14, and finally F for 15. So this is what a hexadecimal numbering system looks like. Now, one of the things that we'll notice about a hexadecimal numbering system is that it is equivalent to half of a byte for every value. So what we're seeing here is 00, which is the same as decimal 0. But we'll notice that the equivalent is all of the first 4 zeros in the binary component are flagged as a 0. 01 is equivalent to 1. It's a byte long, but we are dealing with 4 of the bits here. 0001 is equivalent to 1. 2, 0010 is how we convert hexadecimal 2 into binary 2. Take a look down here at hexadecimal B, which is actually equivalent to 11. We have got the 8-bit flagged as 1. So 8 plus 2 is 10, plus 1 is 11. And that's how we get to 0B. It's a very, very simple conversion. If we had any number in decimal that needed to be converted into hexadecimal, one of the easiest ways to convert it is to actually convert it to binary first. Look at the binary representation of the number. It makes it very easy to understand what the hexadecimal representation is. When we look at these two numbers side by side, we can see the hexadecimal value and the binary value. It's literally half a byte is going to give the 0 through 15. Because when we look at half a byte with all of the binary values flagged as 1s, that's the equivalent of an F. We've got 8, 4, 2, 1, and all of those are added together, and that will equal a grand total of 16 values. And that's what we have here with our F. Now, when we're converting binary and hexadecimal, we always want to use a simple rule of thumb. Break every binary number down into sets of 4. This will make it very easy for us to get the hexadecimal equivalent, as we are never dealing with more than 4 digits at a time. When we are converting hexadecimal to binary, we want to go in the exact opposite direction. We want to take every hexadecimal digit and we want to break that down into 4 binary bits. This is going to give us overall binary result. Let's take a look at a couple of examples.